Namaskar, welcome back. We stopped at this slide and I was talking about that this was one of the major earthquake other than Bhuj earthquake of 2001, and this was 2024 or 2004 earthquake of Andaman. So this earthquake basically taught us many like it taught us a lesson that what can happen because during the mega subduction zone earthquakes. And immediately after this event, there was again a great earthquake of Tohoku 2011, which triggered major tsunami and damage also in Japan. But the damage was not so much as compared to what we experienced in 2004 because we were not prepared for this. So, these are few photographs from great Car-Nicobar, and Car-Nicobar I'll discuss later on about this in a separate lecture. But this is one of the most beautiful islands of Andaman and Nicobar archipelago, and this the photographs which you are looking at right now is from the Air Force and Army base, which was completely ruined. A lot many people got killed here because of we were not prepared for this, and we were not having the understanding about the tsunamis. Okay, and we accept here that we did not pay much attention on this type of studies in India in particularly. Most of us were focused on Himalayas and Kutch because we had many earthquakes in that region, but we never thought of having such large and damaging earthquake which we have experienced in 2004. This was from 2005 Muzaffarabad earthquake, or we can also talk this as an Kashmir earthquake, where the Pakistan side had a lot of damage, but some damage was also got precipitated to the Indian side. And here also many people got killed because of the unpreparedness. Okay. Now, this fault scarp, again what we have been talking about, that how the fault scarps will look like. There is another fault scarp which is along the Thanda fault, and the story behind this is that in 1999 Professor Takashi Nakata from Hiroshima University, he identified this fault as an active fault, an active tectonic landform, informed the Geological Survey of Pakistan that this is an active fault and one has to take the primitive measures, and in future this fault will trigger earthquake. See, already informed this, okay, but the geologists did not take it seriously, and this fault, that is the Thanda fault, ruptured in 2005, resulted into the Muzaffarabad or Kashmir earthquake, what we are talking about. As I told that after 2004, the Japanese scientist or the Japanese scientific community was very much interested in understanding the process of the Sumatra Andaman earthquake of 2004 and associated tsunami, which was triggered because of the displacement of water column in ocean. Now, they were interested. So, the question was why they are so much keen in knowing this process. Their team not only visited, did long surveys in collaboration in Indonesia, but also in India with us. So, IIT Kanpur was party to that field. So, somewhere or the other they knew that similar magnitude earthquake may occur in Japan. So, they wanted to understand the process, and they were the driving force who also guided us how to identify the past tsunamis or the ancient tsunamis or the historic tsunamis, and try to understand the overall process of occurrence and what could be the damage, how much area will get inundated and all that. Okay. So, this is the photograph of the size of wave, that is tsunami wave, which was triggered, and this is, if I am not wrong, is from Sendai prefecture or district, where there was huge damage. And somewhere you can see in the top of the slide that even the vessels were being carried away far inland, and they were sitting in on top of some photographs were there that they were sitting on the top of the two-story buildings. Okay, that was the height of the tsunami which was triggered, and again the magnitude here was 9.1. So it killed almost like 19,000 people. The reason behind this was that they knew, but again they understood well this process. They created the shelter homes and all that, and the rescue places, because they had an history of having similar tsunamis in the past. Okay, but somewhere or the other they failed to some extent to understand the inundation pattern. So, this was again, like if you see that there is a road here, okay, this side, and the ocean is on the right hand side, and they have a wall here which is going on. Okay. So, this wall, what they call is the sea wall. See, height of this wall you can calculate, or you can judge based on the car which has been parked here. So, they constructed this wall, of course, to protect this region from tsunamis, but this was again underestimated. But before this 2011 earthquake, one of the research clearly indicated that they might have a bigger tsunami than what they have anticipated. And if you look at this, this was the scenario of that area. A similar photograph which shows, and there where I have put this wall, the tsunami toppled over the wall. Okay. So, you can compare this, that what was the scenario. Okay. Now, there is one small movie of that same area which was recorded when the tsunami approached this region, and then most of the people were being evacuated. Okay. They went to the higher buildings, and the recording has been done by one of the Japanese person. So, you can look at this, that how the waves came in, okay, and the tsunami is not a single wave which is going to come, but it is accompanied by multiple waves, and slowly the wave heights will increase. Okay. Right now we do not have the sound to this, but when we upload the presentation, we will try to put the sound so you can understand, and that there were sirens which were been like going on, indicating the warning which was well issued. You can see now this wave is coming in, okay, and it is approaching the area, and slowly this area which was exposed got inundated. So, there are multiple waves which are coming up and they will stack up and then build the height. Okay. So, the wall which they constructed was not enough to protect the other side on land from this tsunami. So, you can see this portion is almost now in water. So, I will just move faster. When you get the presentations, you can see it properly. So, this is already inundated, the portion which was exposed. So, everywhere wherever with the understanding of the past tsunamis, they constructed such sea walls. Okay, but that was not enough to protect the area. So, later the larger waves, you can see they have started toppling this area full. And the tsunami waves are barely noticeable in the ocean, but when they reaches the coastal areas, their height increases. So, basically the amplitude what we see of any wave, the wave amplitude is not like the height. Okay, we can say the height is not much in the ocean, not noticeable much. The wavelength is very high, a very large wavelength. So, you can see that the amount of energy uh, with this tsunami wave, which resulted in the damage of many houses. Okay. So, most of the people what they do during this, they are been trained and mock drills are been conducted. So, they are been asked to move to the higher grounds. Okay, or maybe the nearby higher taller buildings. Now, these buildings are definitely very robust and they can sustain the seismic shaking, that is the ground shaking because of the earthquakes, as well as they are not getting like much of damage because of the tsunamis mainly in the coastal areas. So, slowly the water raised up, like, and then you can see the inundation which has gone of the houses which are sitting here. Okay, you can look at the that it has reached almost to the first floor. Okay, and these people, they are been trained in the sense that they are aware that what to do at the time of such events. Okay, so lot many people who followed the instructions were been saved and they moved to such high buildings. Okay. So, this was the house intact which has been now removed by the tsunami, and you can see that it has reached almost to the first floor. Okay. Ground floor is already inundated, and then slowly, because these houses which have been constructed in Japan, they usually try to keep it light, hence they are not very robust in terms of when the tsunami comes, because they have few tsunamis but many earthquakes in this region. So, when you get this lectures, you can try to look at that what sort of damage which resulted. So, there is no seawall. Seawall was somewhere over here. Okay, this was the post which you will realize that it is now in ocean, like total in underwater. Okay. Now, there was another one in 2015, and that was not very far from the Indian side, and it was in Himalaya. Of course, this is the country which is Nepal, and there was a lot of damage again in Nepal, but the damage which could have happened because of such major earthquake, 7.6 magnitude, was not seen. The reason was something else. Okay, but there were few structures which were been constructed were not up to the mark and not as per the building codes. The picture which you see, the photograph where you see one building is been tilted, is a school. Okay, and what they did was that the ground floor or the basement part, they constructed a swimming pool, and that portion was been kept just on the columns. Okay, for example, if you have your building coming up here, so this is your top part or maybe the first floor you are having, and then you go up. Okay, here, but this portion was with only with the columns. Okay, so this was open story, and this got damaged during the earthquake, and that was one of the reason for this collapse. Okay. This is another photograph of the tower, which is again a very famous one, which was constructed using not very strong material. Okay. This also got collapsed, and this was affected in the past earthquakes also. And I don't have the picture right now of the original picture of this tower before the earthquake. I'll show somewhere in one of my lecture. But many people, well, because this was an historical place, so many people, many tourists were there in this tower which climbed up. Okay, and they got killed actually. So the damage which was been expected, as I told, was not much, and the reason behind this was that the ground acceleration was much lower. It did not picked up as it was expected. Okay, like if you see in the this figure, similar magnitude earthquakes which occurred in other places in the globe are been compared. Okay, so the Imperial Valley earthquake 1940, Loma Petra, then Kobe earthquake, North Sea earthquake. These were of magnitude 7.5 to 7.6. Okay, so the ground acceleration which was been experienced during this earthquakes, okay, was much higher in a very short period. Okay, so the damage was more, but in the case of Nepal earthquake, that is Kodari earthquake of 2015, the seismic shaking or the ground acceleration was very subdued in nature, and that saved most of the people of Nepal as well as of Indian side. Okay, at Indian side, this was one of the reason for this. Okay, so the ground acceleration was not as expected. So the part here, what we were talking about, the active tectonics. The term active tectonics refer to those tectonic processes that deform Earth crust on a time scale of significance to human society. So we are interested in knowing the deformation or the tectonic processes which are going to affect the societal, so human society. Okay. We are mostly interested in knowing the processes that were responsible for the disruption of any civilization. So, we are just not going to talk about that the earthquake occurred and this was the ground acceleration, this was the ground shaking and all that, but we will try to understand that how this earthquakes or the processes are affecting the human society. So, we are interested in knowing the processes that were responsible for the disruption of any civilization in a span of several decades or several hundreds years or since the evolution of modern construction, because we were talking about the buildings which were responsible for killing. So, in this part we are also interested that how this earthquakes, this major earthquakes are going to affect the buildings, lifeline structures, dams, power plants, nuclear power plants, etc. So, in order to predict tectonic events, okay, and that is basically earthquakes, over this period, we need to study and understand the tectonic processes over a much longer time scale, okay, for at least several thousands years to tens of thousand years. So, let us say that if we are talking about this, then we are interested in like last 10,000 years, okay. So, we want to have that sort of an understanding. The reason behind this is because the recurrence of large or giant earthquakes on a particular fault may be longer. So, you may say that okay fine, in last 1000 years there is no major earthquake, or 700 years there is no major earthquake. So, you can't say that no, there won't be any earthquake in future. So, for that you need to have some sort of a long term understanding of that process. And we are not saying that you go like taking a very large span of time. Let us restrict to 10,000 years, okay, and try to understand that what are the processes, because the recurrence of large or giant earthquake is 1000 years maximum, okay, or it may vary from 500 to 700 years or 800 years. So, if you understand that cycle or the earthquakes which have occurred during those that span of time, then you can minimize the damage, you can talk about the hazard management and mitigation part also, okay, not only because of the earthquakes, but also because of the tsunamis, okay. So, now the term further active tectonics part, which we have been discussing about, an active tectonic process, we can term that as an or other which is likely to produce a catastrophe in a great earthquake. Okay. However, moderate size earthquakes also can produce catastrophe. We have discussed about that large magnitude earthquakes, then mega earthquakes, and then moderate earthquakes like that. But even in some location, as I think I told this part before also, that even the moderate magnitude earthquake can be damaging if they occur in a densely populated area, okay, and where buildings are constructed of material which cannot withstand the seismic shaking, and that exactly happened in 2015 Gorkha earthquake. Okay. Now, houses constructed by unreinforced cement blocks, bricks or stones, because in our country mostly we are trying to do that type of construction. If you go to village, then you have mostly the houses are constructed by stone blocks and all that, because the building material is available in that way. So, if this is not properly constructed, which can withstand the seismic shaking, so this type of structures are particularly hazardous, or building constructed on thick layers of unconsolidated sediments, okay, and if they are with higher water content. such areas will face tremendous problem even if they are sitting far away. Far away, I am talking about like 300, 400 kilometers, they will get affected. And this is not just I am talking without any evidence, but this happened in 2004 earthquake, and this happened in 2001 earthquake also. The, the, the areas or the towns which were sitting, or the cities which were sitting far away for almost like 250, 300 kilometers, their buildings got collapsed. And exactly the similar process was experienced in this Myanmar earthquake of 2025. Okay. I'll stop here. We'll continue with this uh, information or the introductory part. Still, we are in the introductory part because there are a lot of things which we uh, first know and then get into the details and part. Okay. So, I'll stop here. Thank you so much. Namaskar.